Alright, so let's finish up the notes from yesterday. Do these last couple of examples here. Notice that they're giving us a table, and the table is describing f values, f prime and f double prime, right? Okay, we're going to use that information to answer the questions, alright? So this first one is asking to find the integral from -3 to 1 of f prime dx. So the first thing we needed to do was to find the antiderivative, right? What would the antiderivative of f prime be? F, right? So we go back a function, so this will just be like f of x and evaluated from -3 to 1. So what does that expand it to be? F of 1 minus f of -3, right? And can we calculate those values from the given table?
Yeah.
Awesome. Okay, now there's a lot of numbers in there and there's a lot of room for you to make a mistake. Okay, so be very careful and that you're picking the right numbers. So we're going at f and we're going to 1, so what's the value? -2 minus, now we do f of -3, f at -3. That should be 4, so -2 minus 4, what do we get? -6. Do you understand? We're applying the ideas of an antiderivative, but we're using a generalized function here because we don't know the actual function. Alright, how about number 2 down there? What would we end up with there for the antiderivative? F of x, good, plus f prime of x, and we're going to evaluate that from -1 to 3. You with me? Is everybody okay? Alright, so this is really going to become f of 3 plus f prime of 3 minus f of -1 plus f prime at -1. What's f of 3? 1? And f prime at 3? So 1 plus 3 minus, what's f at -1? 0. And what's f prime at -1? 1. We're going to get 3 plus 1 is 4, minus 1. Our answer here is what? 4. Just a different approach, seeing if you actually understand what's going on. Try number 3, what's going to happen then? Three f prime of x. Okay, good. So that'll be 3 times f prime of x evaluated from 1 to 5. Is everybody okay why it's f prime? Because we had what? F double prime, right? Alright, so let's do it. So we're going to plug in 5. So we get 3 f prime of 5 minus 3 f prime at 1. What's f prime at 5? 2. Okay, what's f prime at 1? 0. So 2 times 3, that's 6. 3 times 0, that's 0. So my answer should be what? 6. Too easy? These are fun, right? Okay. These are the ones you cannot get wrong on the test. You have to get them right because they're so easy. Check out number 4. What are we going to do there? What's the antiderivative going to be? 1/2 f of x, okay? That's 2 times f prime of x. Very good. Evaluated from -3 to 3. So let's set it up. 1/2 f of 3 plus 2 f prime of 3 minus 1/2 f of -3 plus 2 f prime of -3. Okay, here we go. What's f of 3? 1. What's f prime of 3? 3. What's f of -3? 4. Are you guys scared to say it? What's f prime at -3?
-2.
-2. Alright. So 1 times half? half. 3 times 2? 6. 4 times half? 2, but it becomes minus 2, right? Negative 2 times 2? Negative 4? Plus 4, right? Okay, so 6 plus 4? 10, take away 2? 8 plus half? 8.5, right? 8.5? 17 over 2? Yeah? Half plus 8? Are they all equivalent? Yes? Alright. Good? Got the idea? Kindergarten stuff? Alright. So when we come over here, and I give you this guy right here, and we can't use the graph to get the answer because we don't have the graph of f prime, I would have to rewrite it in the way that it should be, right? But I'm not going to do number 10, we're going to look at 11. I'll leave number 10 for you. On number 11, what would be the antiderivative then? So that would be just f of x evaluated from negative 1 to 1. Now where I have to be careful is we forgot to check what we should check from to begin with, right? That the derivative would have to be, this function, which is the derivative, would have to be continuous and differentiable, right? So if I look and I imagine the derivative, okay, what's the derivative from negative 1 to 1? What's the derivative there? The derivative is 2? Right? So if I graph the y equals 2, yeah? Would that be continuous? And would it be differentiable? Yeah, we get 0, right? Okay, so then it works out. So we're good. So yeah, we're going to use f of x from negative 1 to 1. So in this case, we would get what? F of 1 minus f of negative 1. Ah, sir, but they didn't give me a table. Look at the points. They gave us a graph, right? So this is a table, but it just looks different. So at 1, what is the value? 2 minus at negative 1? Negative 2. So 2 minus negative 2, what do we get there? Do you understand the difference? One of them, we're using the graph and finding the space bounded between the curve and adding them up. The other one, I'm just using the graph to find the points in order to use it. See the difference? Check out this one. What's going to happen here? We're going from negative 4 to 0. Right? So negative 4 to 0. What's going to be the derivative of that? Are we going to have two numbers? Because we got to imagine the derivative graph. So what would the derivative of this be? The derivative would be undefined at what? Why? Because there's a cusp, right? So there would be like two values, right? We'd get this number, this slope, right? And then we would get that slope. So in order to draw that, we're going to have one horizontal line, and then there's going to be like a jump to draw the other horizontal line, right? And that's going to cause it to be what right there? Discontinuous, right? So since that graph is not continuous, the derivative graph won't be continuous at negative 1. Then that integral, what? Does not exist. We understand? Yes? Alright, you have to imagine the graph of whatever it is you're working with. I don't have to imagine the graph here because it's given to me. Down here I need to imagine the graph. You understand? Right. Well, not all the time. Sometimes from what you're given, like if this had a hole somewhere here, and they asked you to find that space there, then you would say, oh, it's not continuous. You got me? Good? All right. Come back over here. Let's do the last two examples. What does number 5 want us to do? Equation of the tangent line. What do we need? Pot and saw. Let's go. So what's my pot? Do we know part of it? 3. And what's the y value? 1. Where do we get that from? Table. We need our SOT, the slope of the tangent line. What gives us the slope of tangent line? a derivative, in this case the first derivative at what number? At 3. So what's the first derivative at 3? 3, okay, so what's my equation? Y minus 1, 3 times x minus 3. Beautiful. What's the equation of the normal line? Y minus 1, negative 1 over 3, x minus 3. Okay, cool. So if they ask you for a tangent line, what's the next thing they're going to ask you for? Not the normal line, but an approximation using it, right? Okay, so they want me to approximate the value at 3.1, yeah? So we get that 3.1 and we plug it in there. So y minus 1 is equal to 3 times 3.1 minus 3. That's 3.1 minus 3. 0.1 times 3. 0.3. And they're going to make you do this without a calculator. What are they thinking? Okay? And then we're going to say plus 1. So $1 plus 30 cents. $1.30. Right? Okay, so we could say that f at 3.1 is approximately 1.3. I just answered the first part, right, please? Now let me keep reading. Is this an over or under approximation? And I gotta answer the second part. How do I determine if it's an over or an under? Concavity, right? What describes concavity? Second derivative. If it's positive, it's concave. Up. If it's negative. Okay, so what's the concavity at 3? How do we know the concavity at 3? Table. Second derivative. That's why they gave you that, right? So second derivative at 3 is negative 3. So we know that this curve is concave what? Down, making my approximation be an over, right? So how can we write that? This is an over approximation. Why? Because f double prime of 3 is less than 0. Could we say, therefore, f of x is what? Concave down? Okay, let's say that. Can we set it another way? Yeah. There's more than one way to skin the cat, right?
I don't know why you would do that though.
Yeah? Well, some people eat cats. Good?
I know,
Any questions? No? Alright, so now what I want you to do is go back to that free response and try to do part B now that we talked about it, okay? What are we going to replace f of x with here? Do we know what that f of x function is? Yeah, it's described up on the top, right? Did I find out what a and what b are for that function? Yeah, so plug them in. The only thing I don't know for that function is what? Is k, but that's what they want you to solve for here, okay? So set up your integral and actually work it out, and then equal it to 32, and you'll find out the value of k. Cool?